Hi, Joyce.
Okay, so section 3.2, I think Joyce, you've already checked this. If so, just kind of skip forward and you won't have to worry about it. But everybody else, 3.2, where did we leave off yesterday in checking homework?
16.
16. Yeah.
Okay, like on 16?
Yeah.
We're on 16.
Where's this blue one?
Ah, so it is that way.
Final answer! Negative infinity from below, positive infinity from above. So therefore, wait a minute, what does it say it is?
A bleach.
The problem is a cusp. Yesterday we used absolute value of sine to be a cusp. However, I do believe that I disagree with myself yesterday. Sam and I didn't come up with a great example because a cusp doesn't just mean a sharp point. If it did, then why would we have corners, right? A cusp specifically is where the slope of the secant lines approach infinity from one side and negative infinity from the other. They call it the extreme case of a corner. So technically, I need you guys to grab out your composition books real quick. Open up to yesterday, the end of section 3.2. The absolute value of sine, why is it not a cusp, but instead it's a corner? As we came from below 0 of absolute value of sine, what was the limit of the derivative, or what was the derivative, I should say?
Of sine? Is that what you're saying?
Yesterday, the last example that we did, in notes, absolute value of sine. When we came from the left, what were we approaching? A slope of?
Oh.
Wait, we wrote it down, guys. Hold on.
I didn't.
Absolute value of sine, as we came from the left. Remember we took the piecewise function, we had positive sine, negative sine. Then we took the derivative and we had negative cosine and positive cosine. As we came from the left of 0, what was the derivative?
Oh,
it was
1 and negative 1.
Yeah, technically negative 1 and then 1. So is sine, or does sine, technically according to the book's definition, have a cusp?
No,
No.
because
No,
it's not
it has a corner. So what would be a cusp? Use this. But some of the tests are the same, so eventually use the other one. But this one from yesterday, hence the, what function did we name, number 16?
Bless you. It was cube root of the absolute value of x.
Yeah, so we have to split.
This one has
Bless
a
you.
cusp, bless you, because it does have a limit approaching negative infinity from one side and positive infinity from the other. They're very similar in that they're both coming towards a point, but in this one we have infinite disagreement. We have an infinite disagreement, or disagreeing infinite limits, and that's what we technically will call a cusp, okay?
Wouldn't 1 over h to 1 over h and it's going to it's going to 0, my bad.
Does that make sense?
Yeah.
And this one is a negative and it's coming towards 0. So then 1 over 0 is infinite, and then test the sign, positive, squared, doesn't matter, positive, that's positive infinity. This one, positive times a negative, negative infinity. Is that okay? The difference between corners and cusps, at least according to our book. Number next one.
No, I still don't understand why sine, absolute value of sine is not a cusp.
Because they weren't approaching infinity, they were approaching negative 1 and 1. So they disagreed, the limit did not exist, but that's a corner because it's not infinite. It's not an infinite slope or an infinite disagreement. Alright, number next one.
Are we just doing evens or can we do all the ones that we have?
We're going quickly through evens, then we'll get you to the boards for the odds because you already knew what the work was and you could check in the back.
38.
38. Final answer is they're both discontinuous at 0. B. What did they mean? Do you guys look in your book? What did they mean by ender?
The numerical derivative.
You have numerical derivative in your graphing calculator, so n derives specifically.
Oh, is that what it's
Yeah, numerical derivative means finding the derivative at a value like n deriv does in your calculator. Does that make more sense?
Yeah.
And then the old-fashioned notation before your new calculators that do the cool little DDX, it would just be n deriv. They just cut it short, and it would be function, comma, point at which you're finding the derivative. So this notation is literally just like programming language for take the derivative of 1 over x at 0. But what are they showing? When you use the n deriv, did you guys actually use it in your calculator?
No, I didn't know what to do on this
I
one.
was really confused. I had no idea what they
Sad
were asking.
time. Because your calculator would have actually punched out a number. But why is that weird? What's the derivative of 1 over x?
1
1 over x
Well, the general derivative
would be
is
negative
negative 1 over
squared.
x squared. Plugging in 0,
Would give you not infinity. No.
yeah, it'd be infinite, right? It'd be negative 1 over x squared, that'd be negative infinity. Wait, negative infinity? Negative
Yeah,
infinity.
negative infinity. My bad.
Hold on, get your calculators out. Why isn't this a negative number? Now I'm even more confused. So it does look infinite in the sense of it's getting bigger and bigger, your calculator, but I'm still a little confused.
Maybe it knows to do the thing. You could just take it like a really small number or something like that.
Yeah, but the answer technically is negative infinity, so this is not going well. Maybe it depends on exactly what side you're on, because it does approach positive infinity from...
It says positive.
Really?
So we do n deriv.
Where are they putting the number?
It's the function in the such that is at x equals 0. Yeah?
Mm-hmm.
Yeah, I'm getting one with a bunch of zeros.
I'm gonna go with 6 zeros.
Yeah, it's 6 zeros.
But if you guys were looking at the paragraph above in number 38, recall that the numerical derivative can give meaningless values at points where a function is not differentiable. Long story short, can you trust your calculator always?
No.
So what's the correct answer for letter B? And letter C kind of has you thinking through this. The correct answer for letter B would be negative infinity. The correct answer for the second function, that'd be negative 2 over x cubed. Which would sometimes be a negative, sometimes be a positive. That would technically be DNE completely. Letter C is talking through saying that they are defined, and so the numerical derivative is looking at actual points, but they differ, so they get really super confused. But long story short, I was just giving you this one just to show you n-derived. We use it from time to time, but it's not always correct. There's only so much that our calculator can do. That was a long story short, the whole thing. Next one.
Wait, so that one was just.
That was the last even.
That was the last even.
I have a question on 35 and 39.
Yeah.
I don't.
me too.
35.
35 and 39.
No. 35 I got. 39 I
Do you want to do it on the board?
I do.
Wait, is that what we were
Does
doing?
anybody have any other ones besides 35, 39? So if we can get everybody on the board with one problem at least.
Number 9.
Remember which one?
I can do 9.
Number 13.
Yeah, I can do 9.
Number
I can do
13.
13 or something.
Okay, so George has 9. Who has 13?
Do you have 13 or
I have
no?
13.
Can I do 9 and you do
Yeah.
13?
So
Okay,
9
9 and 13. What were the other two? Gerardo, which one did you take?
Took 38. Or 35. I took 35.
35. And what's the other one? There was another.
39.
39.
I need help with 39.
Amanda and Jackie team up on 39.
God.
That one's Alright, grab a space at the boards. I'm gonna extend.
Oh,
Grab a spot, grab a marker. Your markers are hidden.
Enjoy this part.
So I'm doing 13 now?
Yeah, make sure you label it. Thank you.
Well,
Work
it was
through
big,
from
man.
beginning to end, showing rationale and work.
40.
Plug it into green.
Do you want us to write all by word? Because I really don't want to.
Okay. Oh, obviously you left the pen.
Just talk it through. It's okay. Let's go ahead and grade our section 3.3. You guys have a colored pen still, yeah?
Oui, oui.
Oui, oui.
Ma chérie.
Oh dear.
I speak the French.
Alright, you guys gotta keep me on track. So, hold on. There we go. What evens did I give you?
All
10.
of it.
Not all of them. Number 10.
Oh, no. You misunderstood which even numbers.
Oh,
Not
which
were they
even
all
numbers
evens.
did I get?
No, they are all.
Yeah, but that wasn't what she was asking.
Which,
Got it.
yeah, there you go.
Got it.
Number 10. Horizontal
Okay.
tangents at 0 and 1.
Coisimos.
If you got it right, put a little check mark. If you got it wrong, correct it.
Are we supposed to be grading each other's or is our own fine?
Well, I assume I can trust you, but if I can't, should I have? Are you sure?
Yeah.
Okay, next one.
14.
14a. X squared minus 3 over x squared, or another variation could be 1 minus 3 over x squared. Both of those are correct.
Wait,
That's what D is.
isn't that what B
Oh,
is?
just another way of writing
On
it?
a seal.
Well,
Oh,
they
I
asked
see.
you to solve it one way and then solve it another way.
One. Okay, so both of them, yes, are true. The next one
16.
is
Wait, let's go back up to B real quick. I was looking at the wrong problem. I was looking over there, I was like, that's not even close to what I got. There we go.
1 minus 3 over x squared. Number 16. 5x to the fourth plus 3x squared plus 2x. 5x to the fourth plus 3x squared plus 2x. Number next one.
I liked the homework.
24. A, B, C, and D.
Name of 6, name of 3 has new teachers, right?
A, 2.
B.
B, negative 10.
What?
I don't know.
Keep going.
Hold on, correct it. You gotta correct it first, then we'll go back.
Oh.
Correct it first. Try to put an X through your incorrect answer and put the right one. We'll get back to it. 2 is A. B is negative 10. It could just be wrote down the wrong problem. C is 10/9. And D
I thought D was a trick
is
question.
negative 12.
Wait,
Why?
What?
because they're all constants.
I don't know what I did wrong.
Here, check it out. Make sure you wrote down the right problem. Did we get negative 12 for D?
No. We'll come back to
No,
it.
no, no, but like we wrote it down.
For D.
Oh, yeah.
Yeah. Alright, what's number next one?
28.
28. Final answer. The equation of the tangent line is 2x plus 5, right?
Yeah.
And then the derivative is 2x to the fourth minus 4 all over x cubed. Did you read this one okay, Jordan? Don't worry, we're coming back. They
Oh,
missed letter D.
28.
Yeah, so 28, the derivative is 2x to the fourth minus 4 over x cubed. And then the equation of the tangent line is either y minus 3 equals 2 times x plus 1, or y equals 2x plus 5 is the
I got
slope.
y equals negative 6x minus 3.
Oh, better write it down. That's not right.
We'll come back to this one.
But you checked your derivative too, right?
Yeah, the derivative was 2x to the fourth plus 4 over x cubed.
Oh,
Minus 4. Don't tell me I killed another seal. I killed another seal.
Y prime of 2 is...
yeah,
or y
you
prime
did.
of negative 1 is 2, and then 3.
Something went wrong with your negative.
I didn't have to simplify
The
that.
negative one.
I did that twice
No,
already.
you
this
didn't have to
homework. What's
simplify.
wrong with me?
Number next one.
34. 34 is right there.
First derivative 2x plus 1, second derivative 2, and then the rest are going to be trivial because they're all zeros, yeah? Number next one.
36.
Negative 1 over x squared. Positive 2 over x cubed. Negative 6 over x to the fourth. Positive 24 over x to the fifth.
What? It says negative 2x cubed? 2 over x cubed?
Negative 1 over x squared. 2 over x cubed is the second derivative. Negative 6 over x to the fourth is the third derivative. And 24 over x to the fifth is the fourth derivative.
How'd you come by that?
Power rule. Kept on bringing down negative powers and then subtracting 1.
38.
We'll come back. 38. Was he the last one? The tricky one?
Yeah, he was the last one.
I'm not exactly sure what it was asking.
The last part was weird. It was like,
Yeah.
at what value of x does the curve have... Oh, wait. No. What is the smallest slope of the curve?
It's 0. That's the smallest slope.
The
Smallest slope would be the
1.
minimum.
So it'd be 0.
Oh, like local min.
Yeah. So you can do like a local
It
min.
was 1 at x equals 0, though.
So you
That
take the
was like-
second derivative and you get 6x set it equal to 0, which would be at x equals 0.
Can you say that one more time?
Because if you want to minimize something, remember we can just take the derivative, find the critical numbers.
Oh,
Technically
and then back
centered.
into the original. That's it.
I knew you had to do critical numbers, but I just didn't get out my Ferraris. I was lazy.
Ah.
I looked it up on the internet because I had no idea, and it was like, do a bunch of these weird steps. And
But if you also think of this function itself, can't you just think of if x is positive or negative, it's going to be growing, right? But if x is 0, it's going to be the lowest possible. The nature of the quadratic.
Miss.
So slope is 1 at x equals 0.
Yeah. The slope is 1. The smallest slope is 1 at x equals 0.
Wait a minute.
Uh-huh.
Where did you get x plus 1?
X plus 1. Where's
Y
x
equals
plus 1?
4x plus 1 minus 2.
Oh, plugging in the x plus 1 right here?
Yeah.
I
I got 4x minus 1.
Because it's at x equals positive 1 or negative 1. So there are two different variations, but there's one x minus negative 1 and x minus a positive 1.
Oh, okay.
So
Oh,
because
yeah.
there are two x values, so two equations.
Those are the tangent ones, right?
Yeah.
Cool.
Smallest slope is 1.
Equals 1 when x is 0.
I had the x is 0 part, but how did you get that it equals
Oh,
1?
just plug it in.
You plug in. You
Plug
set
into
that
the
equal to
equation of the
1.
slopes to the derivative. So
Oh,
the slope
okay.
equals 1 at 0. So it's like last year, the minimum value is 1 when or at x equals 0.
Okay.
We're going back to letter D.
No, because that.
Can we?
How did you find figure that that's this? Because the min?
You find
Yeah.
the derivative.
Yeah.
You get the critical numbers. You take the critical numbers. You plug them into the original.
And then you test which one's lowest.
Maybe.
And there's only one critical number anyway. The derivative of 3x squared plus 1 is 6x. Set equal to 0. Critical numbers. That's only at x equals 0. So x equals 0 is our only candidate. And if we think about a parabola, which represents our slopes, the minimum, the horizontal tangent line, will be at the minimum or the lowest. So 0, x equals 0, is the lowest this parabola can go.
Mm-hmm.
And then we just plug it into the equation of the derivative to figure out, okay, well, whose or what slope is at x equals 0.
Okay.
So 3 times 0 plus 1 is 1.
Right. But what did you talk about the second derivative?
Critical numbers.
The second derivative.
That's a way of finding it without having to think through the nature of the quadratic. Because if we had a cubic or if we had a quartic, there is no formula or way of knowing exactly where that is without taking derivatives and finding horizontal tangents, which will occur at all of those minimums and maximums.
Oh, so the second derivative,
Equal to 0.
y is equal to 0?
Finds me the horizontal tangent, which will be at a min or at a max.
So if you set the second derivative equal to 0.
It's at 0. Letter D, we're supposed to be finding, use the result from part A. What was part A you were asking for?
Part A was
The product rule
product rule, yeah.
at 0.
At 2. Wait, oh, you're on the wrong one. It's supposed to be.
Oh, you're right, sorry.
Yeah.
At 2. Okay, so the product rule at 2 equaling 2, right? Yeah.
A equals 2.
And then for letter D,
I just thought they were all constants, so that was 0. Because you represented a constant.
no,
Yeah,
U and V
no.
represent functions.
Because it's
Oh,
the
that's true. I
derivative
didn't
in
realize that.
to x.
Mm-hmm.
What's that whole thing they're doing with the...
Even if they give us like u equals this,
They also give you v prime equals.
Right, so that you only know U equals at one point, you don't know.
but we're testing.
It's
it
not a
out.
constant function. But that's the same reason like saying, what's the derivative of x squared at 4? So plug in 4, like, oh, x squared has the point 416, the derivative must be 0 because it's a number. Well, no. It's part in bigger context of a curve with a slope.
Okay.
There's just a number that represents that point. Does that make sense?
Yeah.
I would love to go over more questions, but I think we need to pause just so we can look at what 3435 is. R. Awkward. So let's pause. There's a lot of time. If we have time, we can go back to questions. Otherwise, I'll take questions tomorrow in class when some of you are here and some of you are not. Does that sound good?
And then test is Thursday?
Yeah.
Okay.
Do we have homework tonight?
Yes. On 3435.
which...
But 3435 is literally. One second. I'll get you guys something like numbers. I'm gonna start writing it there. Write something. Alright, we're not gonna take tons of notes, but basically, long story short, 3-4 has to do with a little bit of related rates, with cubes expanding, etc. A little bit of related rates. A lot of physics, so a lot of motion. Not a lot, like I'm not giving you tons of problems, but motion in the sense of displacement, acceleration, speeding up, slowing down, those sorts of things. And then 3.5 is literally just having to do with trig, how to take derivatives. Okay, so it's not impossible, it's not crazy. 3.4 pretty much just has word problems.
Are they separate in our notes?
See, should we take pictures of the ones we did on the board, or does Mr. Trapani not use the boards?
I'll take pictures for Joyce. Just in case she has those questions.
Or does he use this
But
one
she was
too?
checking with the solution manual yesterday, so theoretically she's probably okay because she already worked through some of the questions, but
Okay.
just in case. Sorry, Amanda, what were you saying, kid?
Does he use this room?
Next period.
For what?
Algebra or geometry.
He also teaches in Dr. Tramel's old room.
Yeah, he has
And Mr.
106,
Park's room.
102, this room, and Mr. Park's room, I think, are all of his rooms. If I remember right. Okay. Rates. We haven't explicitly said it, we just kind of breezed over. I'm not even close to the right section. What's going on? We already talked about the difference between obviously instantaneous and average, but a few different things since you guys are having like word problems from physics. I just wanted to review a few. This isn't in our entire coverage of related rates. This isn't our entire coverage of related rates, but just quick review. Because we have intro to related rates in this section. You guys have already seen it a couple times in other sections as well. If we have something like a cylindrical, which it wouldn't quite be cylindrical, but that's okay, balloon, whose radius is, let's do like 1/4 its height. And if we wanted to find the rate when r is equal to 2, we'll say like the balloon's being blown up. Find the rate, maybe a better way of putting it, let's say, find how fast volume is increasing when r equals 2. Okay, what will we do?
Take the derivative and plug in
Good, but derivative of who?
of the function of s. The
Of volume, right?
it's
And volume of a
length
cylinder.
times area of the cross section, so pi r squared times
Yeah. So area of the base, pi r squared times height. Do I want to take the derivative right now?
Yeah.
No, we want to plug in h.
Yeah, problem is, if I take the derivative, I'm going to have a dv and a dr and a dh. I'm going to be in a little bit of trouble.
Okay.
Because I only have one constant to plug in.
So radius is 1/4 of h.
Would be 1/8.
So just time. So if radius equals 2, multiplied by 4, 8 equals h, right?
That'll tell me the volume, but how to figure out how fast? I need to take a derivative,
No,
right?
it says radius equals 1/4 of the height.
Right.
So if you want to take it with respect to the radius.
But I don't want to be plugging in constants yet for the same reason before as George. This is continually expanding. I can't make it into a constant function. I'll plug this in later. But I could go ahead and plug in, for instance, h is equal to 4r, so v is equal to pi. I could get rid of h by putting it in terms of the other, right?
And then 4 pi r cubed.
Uh-huh.
And
Then I could find a
dv
derivative.
dr of 4 pi or 12 pi r squared.
With respect to radius, sorry. You don't have to do it with respect to time, we'll do it with respect to radius. So we can say dv dr is equal to 12 pi r squared, right? And then we would go ahead and plug in such that r is equal to 2.
And then we'd find, and then we'd get 4, well, I can't count.
48 pi.
40 and 8 is 48.
Yeah, 48 pi. What would my units be?
You don't give us how fast, so can we just assume like
What if I was to go ahead and put in 2 inches?
yes,
Then what?
inches per second?
No, because it's not with respect to time. Related rates usually
Oh.
is. But this is kind of like just an intro, just dealing with taking derivatives of, like, hey, the volume of the cylinder.
Inches per like volume, right?
Yeah, so volume would be
Cubed.
technically inches cubed per inch.
When
And you're thinking inches squared, but remember we want to have it in context because volume is changing with respect to radius, so we'll say inches cubed with respect to, it'll increase 48 pi. The volume will increase 48 pi inches cubed as the radius increases 1 inch. Does that make sense? So that's why we keep it separate, just to keep it in context. So you guys can see that just a little bit, just reminding us there might be an extra clue to plug in, like before you can actually take the derivative. But otherwise, we're just thinking about geometry, thinking about formulas, taking derivatives like normal. We're not doing DDT necessarily yet. Help me out real quick, just thinking about physics and position. Yes, we can call it S of t, x of t, they can name it something else. What does it mean if my position is positive, or my position at a particular time, I'll just keep it t, is negative? What does that mean? Remind me real quick.
just starting
If it's
point
positive
is
to the right of where you started.
Okay, it's to the right of your starting point or to the left of your starting point, right? So we can say it's to the right. The position is to the right, or the position is to the left. Does that have anything to do with what direction it's moving in?
no. It's
Nothing.
going up and down.
This just tells me its actual placement, but it could be to the right of the starting point and moving left, or to the left of the starting point and moving right, or it could be stopped to the right, right? So then we have to, in order to think about how it's moving, think about velocity. Velocity, remind me real quick, who's velocity?
X prime.
The rate of change of position, so hence we would go ahead and think about it as x prime, or we could think about it as dx dt or ds dt with our derivative notation. What's going on if my velocity at a certain time is positive?
Velocity is probably
The rate at which.
The rate at which it's changing, that's one way, that's kind of awkward wording.
Yeah.
velocity is positive, then it's not speed. The
Not
speed is velocity and acceleration.
The first derivative is positive or the first derivative is negative. We're not saying it's to the right or to the left or above or below.
No, that's
No,
acceleration.
Increasing or decreasing, right? But what's
Wouldn't that be
increasing?
acceleration? Oh,
Well, it depends on what you put before that word. What's increasing or decreasing if velocity is
x of
positive?
t
Uh-huh.
is.
yeah.
So the position is increasing. And what does that usually mean in context of a problem?
It's positive.
It's moving
forward or
moving right, remember? Because if its position is increasing, we would say that's moving to the right if it's rectilinear motion. Moving right or up. That's why gravity is negative, because it's pulling it down, making position decrease. Velocity negative, x of t is decreasing. And how do we put that in context specifically with motion?
Moving left or down.
Moving left or down. Now, once we get into polar, we'll be able to say not just right, left, not just up, down. We'll have it all together, but that's going to get a little intense. Gerardo, go ahead.
It's just in physics, it's not really. It just makes more sense to me. Would it be better if it says if xt is positive, it means that you're going in the positive direction?
No. If x of t is positive, you are positively displaced, which means you are to the right, but you could have a negative velocity and be headed the other direction. So velocity sign has to do with which direction you are headed, you are moving in. Position sign literally just has to do with your location at that instant. Does that make sense? Okay. So we have position, we have velocity. Let's keep going. What's next? Before acceleration, speed. Help me out. Just who is he?
Absolute
It's
value.
absolute value of velocity.
He's the absolute value of velocity. We also say something to the effect of he's the magnitude. What do I mean by that? Kind of like with vectors, magnitude always positive. It's just how much is there. So we're just talking about the how much, the how fast, without the direction itself. How do we know speed increasing or speed decreasing?
Acceleration and velocities signs. If they're the same, then they're increasing. If they're different, then they're decreasing.
And technically have the same sign at an instant or on an interval, right?
Yeah.
Because they don't have to have the same sign for an entire scenario. Something can be speeding up 1 second and slowing down the next. And speed is going to be decreasing when
They have different signs.
velocity and acceleration have different signs at a certain point or on a certain interval. And I'm not exactly sure if it gets that intense, but there definitely are quite a few application motion problems. So I wanted to make sure we had that. Acceleration, who is he?
Second derivative.
The rate of change of the rate of change of position. So we could name him as x double prime. He's the rate of change of the rate of change of x. Or b prime.
Part of P.
And his signs, we would say if he's positive, velocity is increasing, right? And if he's negative, velocity is decreasing. But is that necessarily the same as speed?
No.
No, so be careful. Jerk! Who's he?
Me.
No. He's the third derivative.
What? Did we do that last year?
No. You'll see him in section 3.5 just a little bit. He's the third derivative, or the second derivative of velocity, or he's the rate of change of acceleration. Basically, the only other thing you guys are going to see besides things like displacement or what's the acceleration, what's the instantaneous rate at, use all of your shortcut rules, is section 3.5. Just a few derivatives. Just a few derivatives and trig. So have those forever cards close and try to especially with those trig because it takes a little while to figure out.
Are these the only people in your class?
Yeah.
For this one, yeah. Well, no, there's another one. She just watches the videos later.
She's not in the class, but she's.
Why is it such a small class?
It's hard to get to.
What is it?
You have to like skip
You have to be
classes to get
against
there.
your
class. What? Unless you're Sam and like, you know, started a very high level of math freshman year.
Bye, guys.
Cheated my way in. Ask her, she's in my